Hello, welcome to this lesson of our study of Calculus 1, so particularly absolute value problems. Okay, if you remember in our last discussion, we talked about absolute value equation problem where the sign was just only equal to sign. Okay, that was linking the number or the right part of the equation and the left part of the equation. Okay. So today we're just going to go through absolute value inequality problem. So if you have an inequality that consists of absolute values, how do you go about it? Okay. All right. So we just use questions to explain all the possible forms of absolute value inequality problem. Okay. All right. So if you have not subscribed to the channel, kindly subscribe to support the channel. Let's start. And the first one is saying that we should solve this absolute value inequality problem. This one, that is absolute of the expression 3x plus 4 plus 5 is less than or equal to 3. Okay, so but before you solve this, if you remember in the absolute value equation problem, we said that what you do is you have to isolate the absolute value. Okay, so here I just write my absolute value expression, then I send the 5 to the other side, so it becomes 3 minus 5. Okay, and now this becomes 3x plus 4 less than or equal to negative 2. Now when I have an absolute value which is giving me this, after simplifying, if I get this, what does this mean? Okay, what it means is that the absolute of everything that I have in the expression will always be less than or equal to negative 2, which is a negative number. Okay, but if you remember in our previous discussion, we said that absolute value will always be equal to either a positive number or it will either be 0. So there's no way an absolute value expression will be less than or equal to a negative number. So it means that there is no solution to this. Okay, so no solution to this question. That is solution. Okay, I hope you get this. All right, let's move on to the next question. The next question is saying you should find x, or you should solve this problem where we have absolute of the expression x minus 6 or plus 6 greater than or equal to negative 4. Okay, so let's try to make sure that we isolate our absolute value. So like this should be greater than or equal to negative 4 minus 6. Okay, and that will still give us a negative number greater than or equal to negative what? 10, right? Now if the absolute value is greater than or equal to a negative number, and solution is all real numbers. Okay, the solution to this question is all real numbers because the absolute value of every real number will be greater than or equal to a negative number. Now let me tell you one thing. There is no way. There is two conditions here. Okay, so is this, we are saying that the first condition is greater than negative 10. The second condition is absolute of x minus 6 is equal to negative 10. Okay, we know this is impossible from our previous discussion, so this is not part. So you don't look at the negative aspect. Okay, it can be greater than. If it is only greater than, then we are okay. But when it still have greater than or equal to, it means that we are dealing with this part as well. Okay, so let's conclude on this part. Now the question is, when x equals 6, we have 6 minus 6. Okay, which is 0, and 0 is greater than negative 10. Indeed, it's true. When x is equal to a smaller number than 6, say 2, we have absolute of 2 minus 6, that will give me minus 4. Absolute of 4 is what? Positive 4, and that's greater than negative 10. So it means that with this expression here, the solution to this question is all real numbers. Okay, I hope you understand it. Okay, so this is just a very simple way of understanding absolute value inequality problem. Okay, so solution is all real numbers to this question. Okay, all real numbers like that. Now let's go to the next one. The next one is, I'm supposed to find the absolute value, or the absolute, you're supposed to solve for x or solve for the argument of x. Okay, remember, after solving for x, where we get to a point that we can solve for x, After solving, you're supposed to plot it on a number line to find out which part will be the solution. Okay, so this is what you do. Solve for x in this. Now to solve for x in this, first of all, you said you are supposed to isolate your absolute value, and in doing so, this is what you do. You solve it like you are solving a linear equation. Okay, so 4 minus 4, then I have absolute of 2x minus 1 less than 0. Now with this, let's analyze this. Would there be a case where the absolute value of anything will be less than 0? No, because the absolute of anything is either equal to 0 or a positive number, and it will be only equal to 0 when the expression in the argument is 0. Okay, so it means that with this argument here, the solution to this also is that it has no solution. We are just walking through these examples so that we equip ourselves with how to solve absolute value inequality problems. Okay, all right, let's move on to the next one. Now I have this. To solve this, I have to isolate it. Okay, so absolute of x plus 1 less than or equal to negative 3 plus 3. Okay, I have absolute of x plus 1 less than or equal to 0. Okay, now with this, if you have the absolute value being less than or equal to a 0, then there is only one solution, because this, like I said in the other one, this can also be broken down into two. Okay, we can write absolute of x plus 1, the first argument is this, and absolute of x plus 1, okay, equal to 0. This is the whole of this. This is what it means. Okay, it's two arguments put together. Okay, so if you remember in our previous one, we just discussed this, the first argument. Okay, we just discussed this one, that when it is less than 0, we don't have a solution for it, but the other one has a solution. So what you do is you solve it from what we know in the absolute value equation problem. Okay, so this, then you know how to do it. When it's equal to 0, what you do is just remove the absolute value. Actually, it's not like that. When you remove the absolute value, this is how it goes. You put a plus or minus here, then you bring your argument in a bracket like that. Okay, then you equate it to 0. Now you solve the positive aspect first. Okay, x plus 1 equals 0 means x equals negative 1. Okay, then you can also bring the other one. Okay, so minus into x plus 1 equals 0. Now whatever you do, you get x plus 1 equals, because you divide through by negative 1, this is what you get, and you get x equals negative 1. That is why we say that when you have how do you call it, absolute value equation where the right side is 0, what you do is just remove the absolute bars or absolute symbols, and then you solve your equation linearly. Okay, so the solution to this is that x equals what? S equals negative 1. Okay, and indeed when you put s equals negative 1 inside this expression, you get negative 1 plus 1, which is 0, and that is equal to 0. I mean the absolute is equal to 0. Okay, all right, let's move on to the next one. We have absolute of x plus 6 is greater than 0. Okay, so here, what if the absolute is greater than 0? When it's greater than 0, it means the solution here is all real numbers except the value that make it 0. Okay, so what you do in solving this is, first of all, you do like this. Like I said, when you move the absolute sign, okay, you bring a plus or minus, then plus 6 greater than 0. Okay, so first of all, you take the positive aspect, so plus. If I take the positive, you know that automatically we get x plus 6, okay, greater than 0. It means s is greater than negative 6. Okay, then we solve the other part. Okay, let me solve it here. Minus into x plus 6 is greater than 0. Okay, then you divide through by negative 1. Sorry, negative 1. And so it means that you get x plus 6 is less than 0, because this is inequality. When you are dividing through by negative, the sign will change. Okay, so I have x is less than negative 6. Okay, are you okay now? So s is less than. So with this inequality problem, or absolute inequality problem, it means that for whatever value that is within this range, s being greater than all the values that are greater than -6, when I put it in the um, absolute inequality problem, it will work, because if I pick something like -5, okay, it is greater than -6, so -5 plus 6 will be giving you 1, where the absolute of 1 will be greater than 0, and it's true. When I pick values that are within this range, it means all the values that are less than -6, okay, and that is -7. When I put -7 in the equation, I'll get, or the inequality, I'll get -7 plus 6, which will give me -1, and the absolute of that is greater than 0, okay. So how you write the final answer for this is this: you go to your number line, okay, then you sketch the number line like that, okay. Then let's say this is my 0, then I put my, whatever I'm doing, I'm getting -6, okay. So -6 is not part, so this is how the thing is going. The greater than part is this, and then the less than part is also this. I hope you understand this. When you are on the value you are talking about, you check if it is part. That is when it is either greater than or equal to or less than or equal to. But here there is no greater than or equal to, so it is not part. So we don't shade the circle inside, okay. Then you draw your arrow either to your right or to your left, depending on the sign. So with the first one, it is greater than, okay, so it means we will draw the arrow to the right of that number. Now the second one is what? To the, is less than, so it means we draw the arrow to the left, okay. So the interval for this, or the solution for this, is that x belongs to the open interval -infinity, -6, okay, then union, or let me erase it and write it here for you. I hope you understand this. So it's a whole interval like that. So x belongs to the interval -infinity, -6, okay. Some of the books don't write the s belong to, so the solution is this. Then union -6, infinity. You see that we've excluded the -6. That is why I said that if the absolute value is greater than a negative number, the solution is all real numbers, because you can see that this contains all the real numbers except the value that will make here 0, and the value that will make here 0 is what? Only -6. That is why we have an open interval like that, okay. I hope this is okay. So let's go ahead and solve the next question. Now we have this greater than or equal to 0, so we have an absolute of something greater than or equal to 0. Now the absolute is greater than or equal to 0, the solution is all real numbers, okay. Indeed, we can solve and see. So I have plus or minus into x minus 4, okay, then greater than or equal to 0. So I have x minus 4 greater than or equal to 0. That's the first one, so x greater than or equal to 4. Then I have minus into x minus 4 greater than or equal to 0. So I have x minus 4 less than or equal to 0, because the sign will change when I divide through by a negative number, okay. I have x is less than or equal to 4. So if I draw my number line like that, like we did, and if here is 0, this is my -4, okay. Is it -4? It's 4 rather, okay. Sorry, it is rather 4, so this is my 4, okay. Now I'll draw a circle on top of it, and if 4 is actually part, now since we have greater than or equal to and less than or equal to, it means 4 is part, so I have to shade this bracket here, okay. After shading, the first one is greater than or equal to 4, so it means the arrow should go to the right of it, and then the second one is less than or equal to, so it means you should do this. Now this whole thing means that the solution is this: it includes 4. When it includes 4, and then any number around 4 going either to the right of 4 or to the left of 4, so it means that the solution is actually all real numbers. Or if you want it in interval form, it's like this: this negative, this, then 4, then a closed bracket, okay, union, a closed bracket again, 4, infinity. Now you can see that 4 is here, 4 is here, and they are all part. The square bracket here means they are all parts. So if that is the case, then we can join that. We can join these two. We can join everything, because if the 4 that is separating them is part, then it means the solution will be this. Okay, I hope you get it. there will be only 4 that can separate them, and then 4 is also part, so it means it's everything. So it's either you write all real numbers, okay, all real numbers, sorry, numbers, or you write the interval form like this. Okay, so that is the solution to that. Now let's move on to the next question. So I have absolute of 2 minus x less than 8. Okay, so here we are done with the negative numbers and zeros, and now you are moving to the positive numbers. Okay, so if the absolute value is less than or less than or equal to a positive number, this is how you solve it. Okay, so you do it like this. First of all, you bring a plus or minus here. Since there is a positive number, you don't need to say conclude by saying that it is negative, or sorry, there's no solution or whatever. Just solve it like that. Okay, so 2 minus x plus or minus like that equals, sorry, it's less than 8. So first of all, you solve the positive part, which is 2 minus x less than 8, and now you get to, or let me write negative x less than 8 minus 2. Okay, and that will give us negative x less than negative 6, right? Sorry, positive 6. I'm really sorry for that. Positive 6, okay? And now if I divide through by negative 1, I get x is greater than negative 6, okay? So that's the solution for the first part. Now you go to the second part, where you have negative into 2 minus x is less than 8. So I have to divide through by negative, and I'll have 2 minus x is less than negative, sorry, it should be greater than, since I'm dividing through by negative, okay? Greater than negative 8. Now I have negative x greater than negative 8 plus, sorry, minus 2 rather. Minus 2, okay? Now I have here negative what? So negative x greater than negative 10. So I have x is less than 10 because I'll divide through by negative 1 to get x. And I divide through, it has to also change the sign as well. So what you do here is just go ahead and draw your number line. Okay, so if let me draw my number line here at the top there. Okay, now let me draw it straight for you. Okay, now with this one, okay, if this is the number line, let me draw it properly, and let's say this is 0. Okay, this is 0. Let's put 10 here and put negative 6 here. Okay, so what this means is that with the first argument, with this one, s is greater than negative 6, it means just draw a circle on top of negative 6. Then when it's greater than, it means I should draw an arrow to the right of negative 6, so it should be this. Now with the second one, s is less than 10, it means I should draw a circle on the top of 10. Then less than 10 means that I should draw an arrow to the left. Okay, so it means that you could see that the solution is just between the two, the negative 6 and 10. Okay, so what you can do is to write this in an inequality form. You can write it like this: negative 6, you can combine them, okay, it's less than x, and x is less than 10. So it's like this: x is greater than negative 6, which is this part. When I'm reading from here, I'm reading like this: when negative 6 is less than x, it means x is greater than negative 6. Okay, so I read to that side, and x is less than 10. Now with that, you can combine them looking at from the diagram above there. Okay, so from this diagram, from the number line, you can see that this is true. Or you can write it in an interval notation like this: open interval negative 6 comma 10, then close. So the interval should be just open interval like this. Okay, the close interval is drawn like this. It means they are part. Now since negative 6 and 10 are not parts, you draw it like that, open interval. Okay, so I hope you can see this. All right, let's move on to the next question. Now I have 3 times this is less than or equal to 9. Okay, with the other one it was just less than. Okay, so with the less than or equal to, what you do is just isolate. Okay, every time or all the time you have to what? Isolate. So less than or equal to 3. 9 divided by 3 is what? 3. Okay, so here what you do is plus or minus from the I said this, okay, less than or equal to 3. So first of all, 4x less than or minus 1 less than or equal to 3, and I have 4x less than or equal to 3 plus 1, okay, and that will give me 4. So I have x is less than or equal to 1. Then you keep this, and you go ahead and take the negative aspect, okay, minus into 4x, okay, I hope you get this. So negative into 4x minus 1, okay, then less than or equal to 3. Now if I divide through by a negative, I'll get what? 4x minus 1 greater than or equal to negative 3. And then I'll solve this. 4x greater than or equal to negative 3 plus 1 will give me what? Negative 2. So I have x greater than or equal to negative half. Okay, so this is that. S is less than or equal to 1, s is greater than or equal to negative half. So what you go ahead and do is that you draw your number line like we did for the first one, okay? You draw a number line like that, and what you do is with the number line you can indicate your everything on it. So I have 0, and I have, let's say, negative half is here, okay, and I have 1 here, okay. So with what you know, what you do is you just look at it. Since this is less than or equal to, so I take the first argument. Since this is less than or equal to, what you do is you draw a circle on the 1 and you shade the bracket because there's an equal sign under it, okay, so it means it's part. Then since it's less than or equal to, I draw an arrow to the left, okay, to the left of it, and I go to the other one that's greater than or equal to negative half. That one too I draw. Since there's an equality sign under it, I just shade it like that, and I draw an arrow to the right because it is greater than or equal to. Now since this is true, and you can see that the arrows are just merging, it means they are together, okay. Let me put it that way so that you can always see that when the arrows are meeting, it means you can write them like this. So you write the last one, the least one here first. So the solution is negative half less than or equal to, since there is a less than or equal to, you just use that one, x, then less than or equal to 1. That's your solution. Or since the 1 and negative half are all part of this solution, what you can do is you draw a square bracket, okay, the negative half comma 1, then a square bracket. It means it's a closed interval. It means that the ends are all part, okay. I hope you get this. So that is the solution to this question. Now let's move on to the next one. You have 2 times absolute of x minus 1 minus 4 greater than or equal to 2. You know, this time you are dealing with greater than or equal to. So I have 2 into x minus 1 greater than or equal to 2 plus 4, because when a negative 4, you know, cross that, you will get a positive. So I have this. Now I have absolute of x minus 1 greater than or equal to 3. Now with this, I just open it like this, like what I first said, okay, greater than or equal to 3. So with the first one, the positive aspect, I have x minus 1 greater than or equal to 3, and x is what? Greater than or equal to 4. So you are done with this. Then go to the next one. So minus that one, you have minus into x minus 1 greater than or equal to 3. So it means x minus 1 greater than equal, it should be less than, because I will divide through by negative 2. Get that, okay? So less than or equal to negative 3. Now x will be less than or equal to negative 2, because when the negative 1 cross, you get a positive, okay? So this is what you do. Now since this was a positive, you will see that we'll have a different solution. So this is it. You draw your number line like that. Always check this because sometimes it is confusing. Then 0, okay, and I have my negative 2 here, and I have my 4 here, okay, I have my 4 here. Now since this is greater than or equal to, it means the 4 is part, okay, so I shade it like that. Now I draw the arrow to the right of 4, okay. I come to the negative 2 and it's also part, and I draw the arrow to the left of 2 because it's less than or equal to, so it means all the left side of negative 2. Since these two are just separate and they are divergent, they will never meet. This is how you write the solution. You write it like this. Either you write this, x is less than negative 2, or x is greater than or equal to 4. So you are done. But in an interval form or in an inequality representative form, what you do is, since s is less than or equal to negative 2 to infinity, you have an open interval for the infinity, negative infinity, comma, negative 2, then a closed interval because the negative 2 is part, then union, okay? Then you have a closed interval for the 4 because 4 is also part, then comma, infinity with an open interval. So this is how you write the solution. Or in another way, you can also say this. Oh, this is the solution. This is actually the solution. There is no way of writing in an interval, or sorry, in an inequality form. Okay, so in an interval notation form, this is how you write it. Okay. Now let's move on to the next one. The next one is just greater than. Okay, so the same idea. We just apply the same idea here, plus or minus, and it's greater than 4. So I have the x plus 3 greater than 4, the first part. So x is greater than 1. Okay. Now with the second one, I have minus into x plus 3 greater than 4. So I have s plus 3 less than negative 4, since I divide through by negative number. So x is what? Less than negative 7. So you go to your number line with the same thing. When I draw the number line with 0 here, I have my negative 7 here, and I have my 1 here. Okay. So s is greater than 1. It means 1 is not part. Okay, so I just draw a circle on top of it, and the arrow should be at the right. Okay, and less than negative 7 is also like this. So it means it's the same thing here, just that this time they are not part. So I have negative infinity, commas, negative 7, all of them with the open interval union, open interval 1, comma, infinity. Okay, this is a solution. So I hope you understand it. Now with this one, absolute of x plus the expression x plus 3 is less than negative 6. What's the solution to this? Now, first mention is that when you have less than a negative number, there is no solution. So, no solution to this. Okay. I hope you get it. So, there's no way the absolute of any expression will be less than negative number. Now, I have this one as well. So, absolute of 2x minus 4, okay, greater than or equal to negative 3, because I have to divide through by 3. And with this, I just open it. Okay, so you can continue with it. You can actually pause the video and see if you'll be able to solve this. Okay, since you have this greater than or equal to a negative number, so think about it. It will always be greater than a negative number, but it will never be equal to a negative number. Okay, so with a negative number, what did we say? When you have the absolute greater than that, the solution is all real numbers. Okay, I hope you can see, but let's try and solve this and see. So with a positive one, I have 2x minus 4 greater than or equal to negative 3. So I have 2x greater than or equal to negative 3 plus 1, 4. I have 1. X greater than or equal to what? Half. Now with the other one, negative into 2x minus 4, greater than or equal to negative 3. So when I divide through by that, I'll have 2x minus 4 less than or equal to 3. I hope you get this. I hope this is okay. So I have 2x less than or equal to 3 plus 4, that will be 7. So x is less than or equal to 7. Okay, so with this we have a very simple way of solving this. But then, since this was a negative, let's try to, I hope the solution is right. Once our steps are right, let's try to draw or verify this from a number line. Okay, if indeed the solution will be all real numbers. I'm not sure because of the expression inside the absolute value. Okay, so since we are saying that x should be greater than half, so I have 0 here. I have my s should be greater than or equal to half, and s should be less than or equal to 7. So I have my 7 here, and I have my I have my half here as well. Okay, now with the x less than or equal to 7, it means I should shade the circle and then draw an arrow to the left of 7 since it's less than, and to that of the half I draw an arrow on half and I shade it to the right. Okay, since they are meeting here, the solution will be a different case. Okay, so the solution is half less than or equal to x less than or equal to 7. I said when they are meeting, this is what you write. Okay, when they are meeting, this is how you write the solution. Okay, or in an interval notation form. I hope you can write this in an interval notation. Is this a square bracket half, okay, half, then comma 7 with a square bracket again. Okay, close interval. Now let's move on to the next one. We have, I think this will be the last one, or last but one. Okay, I have this 2 into x minus 9. Okay, then greater than 6 minus 6, that will give me 0. So I have x minus 9, absolute of that is greater than 0. And when the absolute is greater than 0, the solution is all real numbers except the value that will make this 0. Okay, so what you do is, what value will make this 0? It's 9. So what you can say is very simple like that. The solution should be negative infinity. I'm just writing the solution. I know you'll be able to solve this. Then 9, okay. The value that will make this 0 is 9. Okay, so this, then union 9, comma, infinity. So it means 9 is not part of this solution. Okay, just go through the process and solve it. I hope you can do it. Okay, now this is the last one. Yes, I guess this is the last one. Okay, so let's try to solve it and see. I have negative 5. Okay, I have negative 5 into how do I call it, negative 5, then I have 2x plus 2, okay, greater than or equal to 0, because when I pick the negative 3 here, send it to the other part, it becomes a positive. Okay, so I have divided by negative 5, I have absolute of 2x plus 2 will be always greater than or equal to what? 0. Now when you have this, at first we're saying that when you have greater than or equal to 0, it means the solution is what? All real numbers. Okay, indeed it's true, but then since there is an argument inside the expression, what you can say is that you just do a plus or minus into 2x plus 2 greater than or equal to 0. Then for the first one, that is the plus, I have 2x plus 2 greater than or equal to what? 0, and then I have 2x greater than or equal to negative 2, x is greater than or equal to negative what? 1. Okay, now let's go ahead and check the other one. With a minus one, I have minus into 2x plus 2 greater than or equal to 0. So I divide through by negative. I have 2x plus 2 less than or equal to 0. So I have 2x less than or equal to negative 2. X is less than or equal to negative 1. Now we have, look at this. We have a case where x is, the solution to this is that x is what? X is greater than or equal to negative 1, and x is less than or equal to negative 1. This does not make sense. Okay, so let's break this into 2, okay, and see. Now the first one, you have x is greater than negative 1 and x is equal to negative 1. Now with the second one, you have x is less than negative 1 and x is equal to negative 1. There's no x that will be greater than negative 1 and will still be less than negative 1. Okay, so it means that the first case of each of them is not valid. Okay, now with the second case is x is equal to negative 1, and this time x is also equal to negative 1 is okay. So it means the solution to this is x is equal to negative 1. There's only one possible way. Okay, Alright, so thank you, and don't forget to subscribe to my channel. See you next time.